pre-calculus. Let's make our answer key for the homework. In class today, we saw this area model as a way of modeling division. To do this divided by that, and finding those outside pieces by kind of like working our way backwards. We'll model this in class. This gives us a third model to use for polynomial division that goes along with synthetic division and like the long division model. So, you know, there are people who like it and people who don't. So, you know, so really there are going to be parts of today where it's like, let's choose like an efficient method. Then there's also parts where I want to use that area model. We have x plus 5 is a factor of a polynomial. Which of the following is true? And this, all right, so if x plus 5 is a factor, now before I even read this, that means that it does divide evenly into the factor. And that means that if we go to x, 1, 2, 3, 4, 5, that means it's going to be a 0 here. So it means that when I go to -5 here, I'm going to get a coordinate of 0 for whatever this weird polynomial does. It's going to touch that point. It may be a bounce or a U-shape or whatever, or it may be you know, we don't know the degree there, but if it's a factor, it divides in evenly, and it is a 0. It is a factor. So if we put in -5, we get an output of 0. That is absolutely true. If we put in 5, it doesn't tell us anything about whether we put in +5, so we don't know that. If we take the function and we divide it by that factor, it would have a remainder of 0, not -5. It would have a remainder equal to 0. So this one's, of course, wrong. It's A is the only one that's right, but let's see, if we take f of x and we divide it by a different factor, we don't know what the remainder would be. We don't have enough information, so this one we don't know. See how that's different than this? All right, so let's move on. What is the remainder when this polynomial is divided by that? Okay, so here's the thing. We can use any method we want here, and I look at this x minus 7, and here's the thing, is that I know if I take x minus 7 and an x plus 4, -7 times 4 makes -28, and the difference between these is a -3. I know that it's going to divide in evenly with no remainder. It is because this is a factor of that. What is the remainder? The remainder is going to equal 0. Now that's one method. If we did this with the area model method, the area model is where I take that x minus 7, I write it here on the side. I'm going to divide that into an x squared, and I'm going to find the other part here. So x times an x would make x squared. So that means that this one would have to be a -7x. But the combination of these two has to add up to a -3x. So that's telling me that this would have to be a 4x. And x times what makes 4x? Well, this would have to be a 4, and that now completes the bottom down here because this would multiply to make 28, which is this. And because those numbers match, there is no remainder. The remainder is equal to 0. It's not that there is no remainder, it's that the remainder is 0. It is a value. Okay. All right, find the quotient. So it means divide these things. Okay, let's use the area model for this one, okay? Now, if we are going to take an x minus 1 and divide that into this, let's see, we're going to have an x cubed, and we're gonna have to go out as far as we need to go out. I'm not going to need all these boxes. I could just keep doing boxes. We're not going to need all these boxes, but an x cubed would go here. The combination of these two has got to add up to -9 x squared. The combination of these two has got to add up to 5x, and then this one is one that's on its own. That means it's going to be the constant one. That means it's going to go here. It's going to be a 3 if it divides in evenly. Let's find out. All right, x times, doing everything in red is like the new stuff. X squared would make that, so that means this would be a -1x squared. But we have -9. That means that this must be a -8x squared, which means that this must be a -8. There's going to be a lot of this x. A lot of this, but this means, but this means, but this means. Now, all right, -8 times -1 would make +8x, but hold it, the answer is supposed to be +5x. That means there must be a -3x here, which means that this must be a -3. And that ends this. The corner number in, so we don't need any of that stuff. -3 times -1 makes +3. Now, yeah. The answer for this one is exactly this. That is our answer. X squared minus 8x minus 3, and the remainder is equal to nothing, 0. All right, so that one worked out nice. Finding the quotient for this one. All right, let me set it up. We got this x and a 4. We'll do the area model. Okay, and let's see. So we're going to have a 3x to the third, and we continue this out. Let's see. Okay, so 3x squared times, so on the outside of our model here, 3 times, that'd be 12x squared. But it's supposed to add up to 5x squared. That means we'd have to take away 7x squared, which means this has to be a minus 7x, okay? See how we're just working our way through that? Negative 7 times 4. Oh my God, I forget oh my God, negative 7 times 4, yeah, 28. Negative 28x, but we should have negative 16x. So the difference between that, though, oh man, that's a difference of 12. That's like a positive 12 has been added in there to get to that negative 16x. Oh boy, so yeah, negative 28 plus 12, verify it, would be our target number of negative 16x. That means that this would have to be a 12, okay, a plus 12. And 12 times 4 makes 48. Uh-oh. It doesn't equal 2, it equals 48. That means there's a remainder here. So we are at 48, but we need to go to 2. All right, 2 is the number we need. How much movement is that? All right, if we're on a number line and we are at 48 and we have to go to 2, that means we will be moving down. How many units are we going to be moving down? 46. So the remainder is equal to a negative 46. How do we write this? How do we write this whole thing out to find the quotient? Well, it would be this part and then that part added together. Our final answer for this is 3x squared minus 7x plus 12. And I have the option of writing plus or minus here. I'm going to do minus, and then I can put a positive 46 on here that's being divided by this x plus 4. That's how we write our final answer. Okay. All right. Let's jump in. So how do we divide these? All right, this is again one where it's like this one we could have done with synthetic division because it's a linear factor. The coefficient in front of this is just a 1. This one, it's like we have to do an area model or we have to do the long division model. Because I haven't modeled the long division model a lot, let's go ahead and do that. If we had the 2x minus 5 and we're dividing into 8x cubed minus 24x squared plus 16x plus 2. Again, like you could do an area model, it's probably going to be easier. But let's talk through what would this be. So I ask myself, 2x times what would make an 8x cubed? Well, I have to multiply by a 4x to the second power. 4x to the second power. I multiply that by both of these parts and I get my 8x cubed, and I get a negative 20x squared. Okay, I'm taking those, but I'm subtracting them from this, so that makes our 0. Okay, and let's see, negative 24 minus a negative 20 is like adding 20 to this. All right, so that would be a negative 4x squared would be left over. And I ask myself, what would I have to multiply negative 2x by to get negative 4x? Well, I'd have to multiply by a negative 2x in order to get that to match up. I bring this term down, the positive plus 16x, and I multiply this by each of these, distributing, and I get my negative 4x squared. Negative 2x times negative 5 makes positive 10x. Okay, all right, and I'm taking this quantity and subtracting it. This minus itself is our 0. 16 minus 10 is 6x. And I look at 6x and 2x and say, I have to multiply by 3, by a positive 3. 3 times 2 would make 6x, and 3 times negative 5 would make negative 10. Here's the thing, we bring that 2 down, bring that positive 2 down, and remember, we are subtracting this. Okay, so we are subtracting 6x minus 6x to get 0, and 2 minus a negative 10 is like 2 plus 10, that is 12. Our remainder is 12. Okay. Whew. Is that right? Man, I feel like I did something wrong here. I did. 3 times 5 is 15. Okay, so 15. I'm an idiot. 15. And 17 is what we would get as our remainder. 17. Boy, oh boy, so many opportunities to make a mistake. Our remainder 17. How do we write this as our quotient? Put it all together. 4x squared minus 2x plus 3 plus 17 divided by the dividend, yeah, by that part there, the divisor, 2x minus 5. And we are done with that. Okay, now, only the first problem has really, nothing here has been dealing with the polynomial remainder theorem. It's, yeah, until we kind of get to some of these other ones. So it's like really the learning targets for this one are some of these other problems. We're going to keep on chugging through. I'm going to do that in video part 2. All right, take care.